Welcome to the Build 3D Importing series. In this session, I will show you how to import files from third-party CAD sources into Build 3D to simplify your geometry creation. This workflow is useful for creating 3D analysis-ready geometry based on files that have been created in CAD software, removing the need to recreate the geometry in Build 3D. There are three methods for importing CAD-generated geometry into Build 3D. The first method is importing as 3D solids. Three-dimensional bodies can be imported directly into Build 3D if they are in the STP or iges file format. The second method is importing as background mesh. Surface meshes that have been created in CAD software can be imported as a background mesh in Build 3D. A background mesh can then be used for 3D sketching or for the creation of a NURB surface, such as topography. File formats supported in this import type include DWG, DXF, or STL format. The last option that I will cover today is importing as a 2D or 3D sketch profile. This third option for CAD importing is through 2D or 3D sketch profiles, which are useful for importing design structures, such as embankment cross-sections or tailings dam designs, into the three-dimensional geometry. File formats supported in this import type include STP and iges format. First, let's talk about the different format types that can be exported from CAD software. When importing in the STP or iges format as a solid, it is best to ensure that the body is a parametric representation. For example, consider these three cylinders. All three cylinders can be saved to the STP file format. However, each have been created in a different way and will behave differently when imported into Build 3D. The red cylinder is a parametric representation. It is an extrusion surface consisting of three parametric surfaces: the bottom, the top, and the curved side. This is the preferred representation of geometry in Build 3D. The green cylinder is a mesh representation of the surface. It contains 50 vertices and 32 faces. Build 3D cannot import the cylinder as a solid, but we will review it during the background mesh portion of this video. The blue cylinder is a polysurface. A polysurface is a faceted NURBS structure. Build 3D will read this representation, with each mesh face read as a separate surface. With this format, you are able to use the geometric operations, but it is not a preferred representation. Let's switch to Build 3D so that we can import this file with three cylinders to further illustrate how these different representations are imported. In Build 3D, we will go to Import Body and choose the cylinder's STP file. This geometry was created in a third-party CAD software where the Z coordinate is the elevation parameter. Build 3D requires a Y coordinate as the elevation, so we will first remap the axes using the drop-downs before clicking on OK to finish importing the file. Here you can see that the parametric representation imported the best, as it was imported as a single solid with three simple faces. The mesh representation could not be imported as a body, so it does not show up in the geometry tree. Finally, although the polysurface cylinder imported as a body, there are now multiple faces for the same solid in the geometry tree. This leads to difficulty with defining boundary condition assignments and generating a clean mesh without first spending time to clean up the solid. Now, let's look at a file that was created using the parametric representation. We will delete this import step in the design history tree and go back to Import Body. This time, I will choose the subway step file. Once the file is remapped to the Y coordinate as elevation, you can see that three solids have been imported in the tunnel design. Now, let's delete that import again. Let's go back to the cylinder file, except this time we will import it as a background mesh. You will see that this time only the green cylinder has been imported, as it was the only solid recognized as a mesh. If the mesh is a structure, it can be used with the Sketch 2D or Sketch 3D commands as a snapping object while drawing. If the imported file is an open surface, such as a topography, it is best to import the mesh surface as a background mesh in either the STL, DWG, or DXF file format. Let's open the ground surface DWG file as an example. We will need to remap the axes like we have done previously. Now, we can right-click on the mesh under the Backgrounds tree and choose Fit to Surface. This opens the Fit to Surface window, which will be discussed in the next tutorial video of this series. The last import feature we will discuss in this video is the Import Profile. Let's switch to a new Build 3D project, which already has a geological model imported via Central. For more information on importing from Central, please refer to the previous video of this importing series. Now, let's say we wanted to add a tailings dam design that was created in a third-party software to review the potential pore water pressure conditions of the underlying foundation following construction. To add this design to our 3D model, we will go to Import Profile. Here, we will choose the 2D cross-section design that was created in a CAD software. Once imported, we will need to ensure that we remap the axes and insertion point to our desired location. Once the cross-section is inserted to our desired location, we can now convert this profile to a solid by extruding it across the geological model. If we assume that nothing was removed from the original topography for the construction of the tailings dam, we can cut the solids using the foundation materials. We have now reached the end of this session. Next time we will discuss the Fit to Surface feature in Build 3D. Thank you.